I made some videos about making rechargeable battery packs and thought that I'd make a series of videos on the basics of doing that and share some of the things that I learned along the way and some of the research that I did. So today we're going to learn about rechargeable batteries, voltage, amperage, power, and the calculations that you can do to make those right for your project. How to select some projects based on some of the projects that I'll share with you. Avoid mistakes and problems. I've made my share of those, and perhaps my experiences will help you avoid those same mistakes. Save some money. You'll save some time too, because I spent hours and hours researching on the web and elsewhere. I've condensed this down into less than an hour. And if that saves you some time, that'd be great. And also have some fun in the process. So let's get started. And you may know some of these things already, and I apologize if I go over things that you know, but not everybody knows them. So voltage is something that you need to know, and there's an analogy with pressure. So the higher the voltage, kind of the higher the pressure to push current through wires to power your device or your application. Amps is the flow of electric current. Amp hours, which is something folks don't normally think about, is the flow of electrical current over time, and you can consider that the capacity or the amount of. So for instance, in a rechargeable battery, if it's labeled as 1 amp hour, it will deliver 1 amp for about an hour, or a half an amp for 2 hours. So the next important equation is power. Power is measured in watts, and it equals the volts times the amperage. I is the current or amperage. So if you take a look at this equation, if you keep watts the same, you can increase the voltage and decrease the amps to get the same watts, or you can decrease the voltage, but you'll have to increase the amps to get the same watts. So that's something to keep in mind when you're doing calculations for your project. This next equation, volts equals amps times resistance, is called Ohm's law. You may use that, you may not, but it's a good thing to know this, and it's volts equals the current in amps times the resistance in ohms. Now, let's talk a little bit about parallel and series packs. So I'm just going to show you one of the packs that I'm working on. This is for a scuba light. It's an underwater light. This pack goes in here and the top screws on for use underwater at night. Anyway, this pack is a 2P, so that means 2 cells in parallel, 4 in series. So here's 1, 2, 3, 4 in series. So in parallel means that the 2 negatives are connected and the 2 positives are connected. That's a parallel set of batteries. And this is the negative side of this battery pack. And the positive is connected to the next series cell. And then the positive of that series cell is connected to the third in the series, the negative side. And the positive side of the third is connected to the negative side of the fourth. And then here is the positive side of this battery pack. Now, when you put a battery pack like this together, it is really convenient to keep this type of arrangement where the parallels are all in line and the series go in the other direction. And I'll give you an example of that. This guy here is a motorcycle battery that I made last year. It's 7P, 1, 2, 3, 4, 5, 6, 7P, and 4S, 1, 2, 3, 4 behind this paper. This paper is for insulation purposes so that this pack doesn't inadvertently hit something in the motorcycle and cause a short circuit, which is not a good thing for these battery packs, or for any battery for that matter. And you'll notice that this whole row is in parallel, and then I've got each of these connected in a series of 4. There are many kinds of rechargeable batteries, like lead acid. For instance, this guy right here is a marine deep cycle battery, and I use that for spot welding with this spot welder to make the battery packs. NiCad batteries, which I talked or mentioned just a little bit a minute ago. Nickel metal hydride is another type of battery. Lithium iron phosphate is another type. And lithium ion is the type that we're going to talk about most in this video. Now, a rule of thumb for all batteries is that when it's fully charged, it's 13% over the nominal rated voltage. And it's fully discharged at 13% less than the nominal rated voltage. So, for instance, a lead acid battery, like that one, at 12 volts nominal, is fully charged at 13.5 volts and fully discharged at 10.5 volts. For the lithium-ion batteries that I use, and I think it's the nature of this battery design, the nominal voltage for an 18650 battery is 3.7 volts, which means that at full charge it's 4.2 volts and at full discharge it's 3.2 volts. And I already shared an example of amp hours, but it's good to go over it again. A 1.5 amp hour lithium ion battery will deliver 1.5 amps for about an hour, and if it powers an LED, like for instance, an LED like this one that uses about 0.3 amps, it'll power that for 5 hours, which is pretty good. And if you want to power it for longer, you can put more batteries in sequence. Now, I bought that particular light from Amazon, and I got, 10 of them for this, and they were not expensive. And here's the specs on that. And you can see that it's 0.35 watts. If you divide 12 volts by 3.5 watts, you'll get about 0.3 amps. So let's talk about projects for a minute. In any project, it is really good to know what the voltage is and what the current requirements are to run that project. And you need to have a good multimeter, and this is a pretty good one. I think I paid about $40 for this. The multimeter should measure DC and AC volts, amps, resistance, be able to check diodes if they're good or bad, and this one has a capacitance feature to it right there. Amps is recorded or measured with this. It's a amp clamp. You put this around the wire that's delivering the amps, and it'll tell you how many amps are flowing through that wire. You also need a source for lithium-ion batteries. Now you can go on the web and check for batteries. You can buy them new. For me, I buy them used, and I buy them from a place called Battery Hookup. They get their batteries from a variety of different places. Many of them are medical packs, many of them are modems. They have new batteries for sale, and they have a variety of associated equipment for making battery packs on their site. The modem batteries and the medical pack batteries and a lot of their other batteries are used batteries, but because they don't get cycled much, more than 90% have 90% of their life left. And you can get these for under $1 a battery. All the batteries that I've used in my projects have been these, and like for instance, this one has been in service since 1/2 of last year, so January last year, and it's still going strong. Holds a charge for under $10. Some of the other things that you need to buy are fish paper. That's what this is, and it comes in a roll. This fish paper is heat resistant, fire resistant, and it's an insulator, which is very important because you don't want to short out batteries. And I'll talk about that more in a minute. Capon tape, that's what this is. And if you've dove into some battery packs, you can see this copper colored tape. And I got these for not much money, really. And they'll last for quite a long time. If you take a look at this motorcycle battery, you can see that the Capon tape is what's holding this thing together and keeping everything in place, along with the fish paper to keep it insulated. The Capon tape is an insulator. It's got great adhesive properties. It doesn't stretch much, but it'll stretch a little bit to make sure that your battery pack is held together firmly. This is nickel strip. Sometimes they're just steel with nickel plating. This, I think, is actual nickel. It's very thin, but because of the width, it'll carry enough current to manage most projects you have. That's what I have holding these batteries together. So they deliver many amps, but not for very long. If you have a high amp draw, you've got to get things that are a little bit thicker. Like for instance, on this battery pack, this is a 10 gauge wire. You have to, if you're going to draw a lot of amps, even for a little while, you need a thicker wire. Otherwise, there's not enough copper to conduct enough amps to run your project. This is a cell grader, charger, and evaluator. What these first 4 cells can do is grade the cells that you put in them, and you select what you want to do with them with these buttons. And when you put a cell in there under the grading thing, it'll tell you how many amp hours this battery is capable of providing. So for this entire pack, all these batteries are about 3 amp hour batteries. And when you make a battery pack, it is important to keep the amp hours about the same. And what I mean by about the same, within about 0.4 amp hours from battery to battery. And the reason for that is if this battery, for instance, is a 2 amp hour battery and this is a 3 amp hour battery, this guy will charge faster than this guy, and also it'll discharge, and over a period of time they'll become so unbalanced that they'll start to heat up when you use or charge them. Or from here to here, if these are 2 amp hours and these are 3 amp hours, the same thing will happen. So it's very important to keep the capacities of the batteries and amp hours the same in the pack. In the next video, we'll talk about low amp draw applications.